this problem, we are given homopolar generator of 1 meter diameter is 1 meter, rotating with angular speed and given is also following induction. Then it needs to find the induced voltage produced by this generator. So here is a schematic representation of homopolar generator. Here is a circuit connected to 2 sliding contacts, one of the side of the generator and another is in the center. There is a constant magnetic field, and this is the direction of the rotation omega and z axis, direction of z axis. So this homopolar generators, they are typically produce high currents with small voltages, which can be used in welding or in some specific situations. And there is also its generator known for Faraday paradox, in which that if magnetic field rotates, if generator would rotate together with a magnet producing this field, it would still give some voltage output, which shouldn't be by Faraday's law. So finding the voltage in this case could be done by Lorentz force, and due to Lorentz force, for this part, we have a magnetic field, constant magnetic field. There is induced electric field E. Induced by this part of the Lorentz force. So what can we say about the directions here of direction V for the particles? So if we take some radius till this point, V will be directed this way, so that it's perpendicular both the magnetic field and the induced electric field, and it can be found from omega. And we see that omega is also perpendicular to the velocity v. So can be found as a cross product of the distance vector r and omega. And omega is in that direction, cross r is in r direction. R cross Z cross R is a phi. So the velocity v is in phi direction. And then for the B field, for induced electric field is cross that direction. So phi cross product Z is R direction. So electric field will be induced electric field will be also in R direction. And here we found the electric field, and we have those two sliding contacts which provides induced voltage. And induced voltage, in other words, is a difference of potential. So instead of calculating the flux over the area, can be found as a difference of potential. And difference of potential for the point, here is point 0 or point O and point P, potential of these 2 points. So what is difference of potential? Is can be written this way, and also if we introduce this line between these 2 points, the distance between the potentials, distance R, we could write dr, and difference of potential in this case would be the gradient minus for the electric field. So the gradient is has direction, and then it's inside the dr there is also r direction. So let's see how this and this can be connected. So difference of potential, the gradient will be then phi dr in r direction, because with a minus for the electric field, and this dr is r in dr, so just 2 give 1, and this cancels, so this how we actually come to difference of how we connect these two parts. And this is basically electric field, so it's electric field along the line between these 2 points. We are given the radius, so these 2 points, one lays at 0, another lays at some distance a. And then plugging this in, the L is our R. And finally, oh my God, R squared divided by 2. Did I miss something? Of course, I missed that. So here is Z. So this was the induced voltage. And let's find the numerical value. So this at 0.1 Tesla. Radius square is half a meter square. divided by 2. And omega is in revolutions per minute. To come to consistent units, needs to be multiplied by 2 pi divided by 60 to come to radian per second, I think. Let me check. Yes, then omega becomes radian per second. And then we get volts. So the answer is 4.7 volts. It's quite small voltage.